Hi, I am Ömer. I am responsible in Siemens for cement business. Today, together with me is Bernardo, our digitalization expert.
Hi, I'm Bernardo.
Welcome to the World Online Cement Conference. Hi Bernardo. We have been meeting cement customers on a regular basis to discuss the challenges they face during operation. Can you name a few major pain points you heard most often from our customers?
Thanks, Ömer, and welcome from my side too. Among the many challenges we heard, here are some examples. Current and upcoming challenges in urbanization and infrastructure, such as unbalanced market conditions worldwide, require flexible cement production with heavily distributed operations and scalable production capacity. This means low market conditions demand highly efficient operations to balance costs, whereas high market conditions require full capacity usage. Another challenge, which I'm sure also rather familiar to our viewers, is to ensure compliance with environmental policies towards a low-carbon future. In this sense, cement factories are challenged to adjust their processes in direction of minimizing emissions.
Not forgetting lack of skilled talents will be an issue not only in remote areas, where it has been always scarce, but also in central areas, where it is more and more difficult to attract younger generations to heavy industry. Finally, as a result of mergers and acquisitions, globally and locally, the resulting cement companies need to manage and control complex and distributed operations, for instance, ensuring quality. Solving those challenges from technology perspective is not always trivial, as several different aspects must be considered. We believe that emerging digital technologies are key to address those challenges as they enable new solution approaches. In this regard, it's essential to define an enterprise architecture. In the following slides, we shall be showing you selected use cases on how to tackle the pain points with our digital solutions. Ready?
Let's go!
So, we introduced different challenges of cement industry, and one thing is for sure. Solving those challenges from technology perspective is not always trivial, as several different aspects must be considered. We believe that emerging digital technologies are key to address those challenges as they enable new solution approaches. The foundation of digital technologies is, of course, the data. A wide range of data sources can be found in a cement production line. Process values are handled by automation systems to control the production, while dispatch and laboratory values, for instance, are usually managed by dedicated IT systems or even spreadsheets. The foundation of digital technologies is, of course, the data. A wide range of data sources can be found in a cement production line. Process values are handled by automation systems to control the production, while dispatch and laboratory values usually are managed by dedicated IT systems or even spreadsheets. By properly integrating those systems under a plant data model, users like operators and site managers have quick and easy access to live and historical data all in one place, as well as they benefit from information generated from the combination of distinct databases. This facilitates routine tasks like plant reporting and dashboarding, asset management, and performance monitoring, and at the same time prepares a data repository for advanced data analytics and process optimization.
As mentioned, the important base for the data in a cement plant is the process automation system. We should be having a solid base as an automation system to be further able to build digital solutions on top of it. In that sense, we are really proud of offering cement-specific library to the cement industry since 40 years. Cement is a leading cement process control system, developed since 40 years as a result of continuous collaboration between Siemens and cement producers around the world. The main issue here is that cooperation inserted all the wishes coming from the operators and process engineers who are running the cement plants. In that sense, we achieved globally the market leadership in control systems in cement industry. We have more than 1,000 cement installations worldwide. And the success based on that real process-based approach. Cement is a comprehensive library with specific features and functions for the industry. Many topics like user-optimized alarm concepts, advanced information dialogues, maintenance features, advanced process control capabilities are specifically developed for the needs of the cement industry. And with CEMAT, we can establish a real solid base for further development in the direction of digitalization and optimization of the cement operations. We talked about various challenges that the cement customers are facing related to lack of skilled personnel and distributed operations. So having key experienced operators to run the plants everywhere is not an easy task. So in that sense, always it comes to mind if it is possible to have a central control room to run or at least to monitor different plants. Through its SIMATIC PCS7 framework, CEMAT already enables remote monitoring and control of the plants. To establish remote operation center is particularly relevant to optimize the personnel in the company. For instance, enabling the best kiln experts to be assigned to operate more plants simultaneously from a central control room. Our concept for central control room design allows the balance between on-site and off-site activities without compromising safe operations. Of course, safety here is the key word to manage the tasks for the off-site and on-site personnel to have a safe and secure operation. Another important topic is, of course, cybersecurity. Industrial cybersecurity becomes more critical as operations are performed remotely. As a leading provider of industrial security, Siemens is actively engaged as one of the founding members of Chart of Trust initiative. Our portfolio is based on defense in depth concept, in which our systems, products and services are integrated to ensure secure remote access at both application and network level. We already mentioned that the success of CEMAT is based on the collaboration together with our customers and the feedbacks that they are giving to us. In that sense, we are continuously improving our solution. An example of a recent development is recipe management functionality, which results from a clear challenge to produce different cement types at the same production line and with short intervals. So we call it scalable production control. The idea here is it could be different applications like cement grinding, preparation of the raw mix or kiln firing. The idea is to define the parameters for a specific cement type or for a specific application so that the operators can immediately start with the production, and if they want to change to another cement type, for instance, with a mouse click, easily change to another parameter set. It will help also our cement producers to manage the challenges coming from the environmental regulations or CO2 emission regulations, like generating different cement types, for instance, less clinker in cement and different type of additives in grinding of the cement.
So we started this presentation by highlighting the importance of plant data model as basis for digital technologies in a cement line. Since many cement producers have several facilities, often distributed across cities, countries, and even continents, the next level of digitalization is to create an enterprise operations transparency while connecting these plants to corporate and management levels. In concrete terms, real-time connectivity to multiple cement plants enables to centralize technical and management tasks at corporate level, optimizing personnel allocation and minimizing fly-in, fly-out efforts to remote areas. As an example, the creation of an enterprise operations data model allows standardization of concepts, indicators, and reports in different production sites and facilitate performance comparisons and internal benchmarking. Integration with enterprise resource planning systems opens new perspectives for operating cost analysis driven by correlations between financial and technical data. In a further stage, this model can incorporate queries, red mix, and concrete stations to generate end-to-end management functionalities such as comprehensive material tracking and overall production planning. As presented earlier, our CEMAT automation solution has the perfect fit for remote control or basic remote monitoring functionalities for cement plants, which are based exclusively on process values. However, applications that require real-time visualization and analysis of multiple databases or multiple plants are better covered by our operations intelligence solutions. Our typical solution package includes data connectors to access in real time existing information network, data modeling to contextualize multi-source data, and visualization layer with structured views for different users and drill down capabilities. Templates for the cement industry are available, but we can also generate dashboards and report views according to our customer specific needs. Typical questions addressed by those solutions are, for instance, which mills had the highest and or the lowest operational costs this month? What's the current benchmark for kilo energy efficiency? With the current pace of production, will I reach my sales targets for the week? What reasons have been reported that led to the decrease in efficiency in cement line? What areas, equipment are not currently in operation? So now let's take as an example the following demo system where several cement mills from different locations are monitored by a central system. As can be seen, the live status of all mills are presented on the main screen, where total production can be easily compared against production targets. The user can also drill down to a specific mill screen in order to get more detailed information about the current performance. As an example of analytical possibilities shown in the right-hand side, through statistical analysis of power consumption and price of electricity trends, the total grinding energy cost profile can be forecasted for this mill and used as basis for increasing energy efficiency. Lastly, performance benchmarking can be carried out through the analysis of historical KPIs of all mills, such as specific power consumption and cement production. As previously said, besides generating operational dashboarding and reporting, an enterprise data model is also the information backbone to integrate the complete operations value chain. Here is a practical example coming from a neighbor industry. The customer is Vale, the biggest iron ore producer worldwide. Similar as in cement operations, this mining company has long and complex value chain consisting of 38 sites, which include mines, process plants, and logistic terminals. Managing the complete operations was a big challenge, and 17 different production management software were previously assisting this task. In collaboration with Vale, we have replaced all those systems by a single manufacturing execution system, especially developed to fit Vale's requirements. Compared to older systems, the new MES boosts shorter downtime because of the more modern and robust technology. The increased agility and the reduction of unproductive hours are obtained by the higher level of integration with automation systems that provide immediate and reliable data, besides requiring less manual work and being more intuitive to operators. Less than 1 year after the system was implemented, Vale has estimated around $70 million of savings due to this project, mainly by boosting productivity, improving asset utilization, and optimizing technology costs. Now let's look to the future. The focus of the so far introduced solutions are part of the vertical integration of cement operations and are summarized on the right side of the screen. The ultimate target for this area should be a seamless data flow between operational, management, and corporate layers, ensuring full operations transparency and perfect synchronization between planning and execution activities across the complete cement value chain. Another aspect of digital transformation is the horizontal integration, where complete life cycle of the plant assets, such as a mill or a kiln, for instance, is managed by a digital database. The main challenge here is to establish a relationship between engineering and operational data, for which the main precondition is that the engineering project is structured as a database and in an object-oriented manner. Typical benefits of this solution would include the increase of efficiency of plant design, project standardization, and improved asset management throughout the complete life cycle. Both vertical and horizontal integrations can be seen as mainly infrastructure topics for data management. We added an intelligent layer to our architecture to close the loop of operational improvement, which leads to the optimized operation level. Different emerging digital technologies such as big data analytics, machine learning, and artificial intelligence can be relevant to achieve such improvements and must be properly integrated into the cement ecosystem. Here we differentiate loops at plant level and enterprise level. Typical plant applications include advanced process control, process optimization, and predictive maintenance, whereas enterprise applications are related to value chain optimization, such as end-to-end material flow simulation. Both loops can be closed either within operations and engineering, depending on the improvement solution. If the optimization leads to a new equipment setting point, then the changes should occur at operations level. If optimization leads to a new equipment layout or process route, for instance, it represents a feed to the engineering solution.
Now let's focus a little bit how we can use data analytics and big data to generate value. There are various stages. In the first stage, the main task is to analyze the historical data to understand what happened. Of course, this is not enough. The analyzation phase is more important in that sense to understand if something happened, why did it happen, so that we can avoid it in the future. The third step is more in the direction of predictive analytics. This is a further step of analyzing the data and making use of that historical events to make fault prediction and foresee any anomalies which are coming up in the right time before, for instance, losing production, etc., and to avoid downtimes. And the last step is prescriptive analytics. So acting also automatically by analyzing the data. In that sense, it comes to self-learning systems, machine learning, and control and optimization of the process. The approach of Siemens is in that sense to combine those technologies and the know-how which exists in Siemens, being the supplier of the automation system since 40 years to the cement industry, but also the domain know-how which is a possession of our customers. Our cement producers are the best experts who know the problems and understanding the data much better than ever. So the idea is getting the data from different processes and sensors, use the domain know-how, but also put the know-how of our customers, combine it with analytics to achieve improved performance, energy savings, cost reductions, etc., etc. In that sense, we can say that Siemens' approach accomplish effective artificial intelligence systems is based on close cooperation between operation experts from customer side in order to capture domain know-how expertise to train the artificial intelligent algorithms. Here you can see it also. If we get the historical data, we analyze it through different type of softwares, categorize the data, and find also correlations between the different parameters. But afterwards, the next step comes that we sit together with the experts from the production so that we can label the data to understand which is a good operational point, which is a bad operational point. And with that feedback, we can train the artificial intelligence system to achieve either anomaly detection or process optimization. Let's give an example from a different field, optimization of the gas turbines. Siemens is producing since many years gas turbines, and of course we have a detailed internal expertise how a gas turbine is functioning. What we did in that sense is use the data and the know-how of the expert to generate autonomous learning and further optimize the gas turbine. As I mentioned, we have more than 30 years of experience producing those turbines. We have a lot of patents and technologies and best available turbines, but still there is a place for further improvement. The control algorithms which have been established by our experts are achieving a perfect NOx production. But when we use that artificial intelligence algorithms and machine learning, here immediately you can see also the difference. So this is the NOx production of a gas turbine with the standard control algorithms. And if we use artificial intelligence and machine learning, how such a digital solution can improve that NOx production, you can see easily. The same approach is also used in cement industry. For instance, let's talk a little bit about the kiln. I think that is the most complicated process part in the cement production. Kiln operators need to produce maximum potential tonnage of good quality clinker at minimum energy consumption. In that sense, they control actually 4 variables: fuel rate, feed rate, kiln rotation, and fan speed. It can be seen as easy, but in practice, the situation is not so simple. There are many challenges that the operators are facing. Feed quality is always changing. Usage of alternative fuels, where calorific values can continuously change, can create, but in practice, the situation is not so simple. There are many challenges, like changing feed quality, usage of alternative fuels, where calorific values can continuously change. So operators have to watch many parameters closely, and especially with their experience from historical trends and from the past, they should control the kiln. For instance, they should understand whether the kiln is heating up or cooling down. As you know, the problem is we cannot really foresee or measure the temperature inside the kiln. There are a lot of different type instruments trying to measure it, but of course the dusty environment and the high heat inside the kiln is bringing a challenge that we cannot really measure the temperature, and the operator should really foresee if it is heating up or cooling down. Best performance achieve in kiln operation a run rate of 95% per year, and an average operation can reach 90%. But there are many factors. Any failure can generate in ring buildings, coating loss, broken rings, and many other instabilities, which result downtimes. And when you have a downtime, of course, you have to cool down the kiln, clean it, make the necessary maintenance, afterwards lighting up and warming up again to a temperature that really we can take again material inside the kiln. And of course you can calculate how much production is lost in that period of time. So really kiln operation is a complex art. You need to have very experienced kiln operators to control that sophisticated process. And until now, for this problem, traditional automation methods, even expert system, cannot be a real solution because all those changing variables like alternative fuels, like the kiln feed, etc., etc. In the secondary fuels, the calorific value can change anytime because of the content of the material and of course the moisture. Now think, what if digital technologies based on big data analytics and artificial intelligence algorithms can be helpful to solve this problem? Here you can see there are a lot of different variables that we can measure. Maybe not correctly the kiln temperature, but many other things. So the idea is, can we make some correlations with artificial intelligence algorithms and foresee the trend of the temperature inside the kiln so that we can adjust the fuel mix, etc. With the support of these algorithms and technologies, it's possible to analyze those different data and find the correlations among them. So we can recognize patterns and optimize the process inside the kiln. In that sense, we can talk also other process parts of cement production, for instance, mills. There is a reference shown here from Portland Cement Plant, Rodorf in Germany, where we did a mill control optimization system by using neural networks. And the idea is using neural networks as a soft sensor to determine the grain size of the production so that we can adjust the variables. And the result is quite good actually. The performance of the mill has been increased nearly up to 8%, and in that sense, the return of the investment was really short. Artificial intelligence can also be applied for automatic anomaly detection in regards equipment health, in order to predict potential failure of critical equipment and minimize shutdown in cement plants. Siemens concept goes beyond the classical condition monitoring of electrical components like drivetrains, motors, etc., being extendable to complete assets. For instance, like a complete mill, including the mechanical components. In that sense, artificial intelligence algorithms enable data analytics into big data as they can identify correlation between different equipment variables and as well as its relationship with failure events. Here is also an example for the big gearless mill drives. So it is a running pilot since several months very successfully where we monitor different variables and predict failures of a complete mill with the mechanical components. Here we are using again machine learning, artificial intelligence and also cloud technologies to use the power of big data analytics. So we try to explain several solutions for the challenges of the cement industry. We can summarize those solutions and offerings from Siemens into two different areas. One is data integration and generating transparency and benchmarking for the distributed operations of the cement plants. Generating executive plant dashboards and of course value chain integration starting from the limestone mine towards the production of the clinker and cement and even transportation and ready-mix plants. So generating manufacturing execution systems. The other focus area, as we mentioned, is the process. One part is remote and autonomous operations to make the life of the cement companies and of course also the operators easier so that their workload is lower, that the plants are operating in more autonomous operations and it's also easy to monitor remotely and use the existing experienced operators in best possible way. And of course, based on that artificial intelligence technologies and machine learning, the focus areas are process optimization and digital predictive services so that we can prevent downtimes in the cement plants, increase the availability, increase the optimization and efficiency of the cement plants.
I hope after the slideshow you have gained some idea what Siemens could offer you. Now you probably ask, why should you choose Siemens as your trusted partner? That's because we understand cement industry and are active for more than 40 years on developing solutions to address cement challenges with proven track record of successful projects implemented in electrification and automation. More importantly, we understand IT and OT as well as how they interact with each other. As a leading IT provider worldwide, Siemens can bring into cement solutions relevant industrial IT capabilities such as big data analytics, machine learning, cloud solutions, and industrial IoT.
Global presence plays an important role as a valued partner. We operate globally and covering more than 30% of cement market in regard to automation systems. Siemens takes innovation seriously. We drive innovation with more than 10% of company personnel dedicated to R&D. And Siemens is currently engaging in different digitalization initiatives in close cooperation with our customers, pursuing innovative business models and developments to meet and exceed our customer expectations. We are sure there are now many questions going through your mind. Send them right to us. On the screen you will see our contact emails.
Thank you for joining us and we look forward to hear from you.
Bye now.
Siemens, ingenuity for life.